Now we're going to look at section 2.7, which is piecewise functions. And piecewise functions is one of the first topics in Algebra 2 that really doesn't get any discussion in Algebra 1, so this might be pretty new for all of you. A piecewise function, you can see the definition right here at the top, is a function defined by several equations corresponding to a part of the domain. Kind of complicated. What it really means in very simple terms is a piecewise function is just made up of multiple functions, pieces of functions, where it will start and stop depending on the x value. So when it says part of the domain, what it's saying is that it's all dependent on the x value you're working with. And the x values, if you're looking at certain x values, you might be looking at one function. If you're looking at a different x value, you might be looking at another function. Most of our piecewise functions today, we're going to start talking about ones that are made up of two pieces, two different functions, but you can have piecewise functions that are made up of 2, 3, 4, or even more different functions. We're going to start with just evaluating piecewise functions. And when you evaluate, you have a decision to make. You have to look and say, depending on the x value you're plugging in, where should I put it? So every single problem, you're going to go through that process in your head. This is what x is. Where does it belong? You're never going to get more than one answer. When you say x is 5, so it goes in this equation, there are no other options. So here's a great example of a basic piecewise function that's asking to evaluate. So f of x right here is made up of this piecewise function. You'll usually see a bracket around the functions. If you're not good at drawing brackets, you can draw an arc, you can draw nothing at all. And then after here, these are the conditions. This is the domain it's talking about. So this is saying if my x is less than 2, any number less than 2, I'm going to use this equation. If my x is bigger than 2 or equal to 2, I'm going to use this equation. So you kind of have to choose your path, decide which path is appropriate. So for letter A, it wants to know when x is 0. So the decision you have to figure out is x is 0 less than 2 or is it bigger than 2? Obviously it's less than 2, so you go to this equation. When you're doing this, you are simply plugging in this number for x. So you would have 0 plus 2 equals 2. This answer right here, this is your y value. So another way to represent it is the point on your piecewise function graph will be the point 0, 2. When you plugged 0 in, you got 2 out. Let's look at letter B. X equals 2. 2 is not less than 2. It is equal to 2. So you have to figure out where is the or equal to here. It's in the bottom equation, so you need to put 2 right here. So your plugging in would be 2 times 2 plus 1, which is 4 plus 1, which is 5. So again, you can just say your answer is 5, or if you prefer to write it as a point, you can say your answer is the point 2, 5. That's a point on your graph. It's the y value you get when you put x in. And then the last one, x equals 4, again, making the decision. 4 is not less than 2, so you're not using the top equation. 4 is greater than 2, so you're going to use the bottom equation. And really, you can start doing this in your head. You don't need to show a lot of work. Put it into the bottom equation. You end up getting 9. So again, you can say your answer is 9, or you can write the point 4, comma 9 is the point on the piecewise graph. Got a couple more examples that you can try on your own. If you want to try them before I do, then you can pause this video and see if you're getting the right answers. If you want to just work along with me, you can just keep playing it and watch what I'm doing. For this first one, we have, again, a piecewise function made up of two different equations. This time, 1 is kind of the changing point. A lot of times I'll refer to that as the changing x value. It's the one where it switches from one function to another function. I'm going to put negative 3. The negative 3 is less than 1, so therefore belongs in the top equation. So you're going to put it in where the x is. So you'll have 2 times negative 3 minus 1, which is negative 6 minus 1, which is negative 7. And again, you can just write negative 7, or you can write the full point. The next one is 1. When you put 1 in, you're going to put it in the top equation, because this is the one where it says or equal to 1. You'll never have that or equal to in both places. If that's the case, then it's not a function anyway, because it would have two different outputs for one input, and that breaks all our rules of functions. So we're going to put 1 into the top equation, so it's going to be 2 times 1 minus 1, which is 2 minus 1, which is 1. And then the last one, 4, if I look up here at my restraints here, or my constraints, 4 is bigger than 1, so I'm going to use the bottom equation for the first time. So it's going to be 3 times 4 plus 1, which is 12 plus 1, which is 13. I've got one more screen, and again, if you want to practice these on your own and check your work, You can pause this, or if you want to just work with me, I'm going to go through each one. You'll notice here, now we have two piecewise functions. So not only do we have to decide which equation we have to put it into, but we have to make sure we're working with the right function. So this, anytime it's talking about an f function, is referring to this one. This is your g function. So the first one, when it says f of 0, we want to go to the f function, and then 0, we look at my choices. I'm looking to see 0 is less than 4, so I'm going to go with the bottom choice. So it's going to be half of 0 minus 3, which is 0 minus 3, which is negative 3. G of 0, now I want to put 0 into this function. Look at my different options for my domains. 0 is bigger than negative 3, so I'm going to use the top function. This is just saying it wants the negative of whatever number you plug in, so the negative of 0, well, there's really no such thing. It is just 0. For the next choice, g of 6, you're going to the g function over here. 6 is bigger than negative 3, so you're putting it here. And really, you don't need to show any work for this. This is just the opposite of 6, which is negative 6. F of 4 saying I want to go over here. 4 is equal to 4, so you're looking for this or equal to tell you to put it in the top equation. So it's negative 3 times 4 plus 1, which is negative 12 plus 1, which is negative 11. For g of negative 5, again, the g function, negative 5 is less than negative 3. You got to know your integer values here to determine that. And you're going to take 1/3 of the negative 5 you're plugging in plus 2. This one is not going to work out quite as pretty. You get negative 5/3 plus 2, which is the same as 6/3, or you could do this in your calculator. You get 1/3. I would prefer that you write your final answer, whether you use your calculator or not, as 1/3 and not 0.3 repeating to be a little more accurate. And then the last one, f of 8, we're going back to the f function up here. 8 is bigger than 4, so we're using that top equation in my piecewise function. So it's negative 3 times 8 plus 1, which is negative 24 plus 1, which is negative 23. So that gives you a basic idea of just how you evaluate a piecewise function. We are going to be looking at how we graph piecewise functions, how we write and use piecewise functions, but this gives you a little bit of a start.